So we've spent the last couple of lessons learning about circles, parabolas, hyperbolas, and ellipses, and we've looked at all of their different equations. So what this lesson is all about is being able to look at an equation and instantly being able to say whether it's a circle, hyperbola, parabola, or ellipse. So I think a good idea would be to quickly go over some of the formulas that we've looked at so far. So if it's a circle, then it has the following formula: x minus h squared plus y minus k squared equals to r squared. So what's interesting is that there typically isn't any numbers at the bottom over here. But if there were numbers at the bottom, then they would have to be exactly the same. Okay? So they would be exactly the same. And what's also important about a circle is that there's always a plus in the middle. If it's an ellipse, for example, then these numbers would look a little bit different, and then this would have to be a 1. Okay? So, but this is a circle. Something like that. Then we look at a parabola. Now with a parabola we have horizontal parabolas, so horizontal and vertical. If it was horizontal, actually let me write vertical first, because when I showed that lesson on parabolas we always did the vertical ones first and then horizontal. So when it was vertical, this is the one where I asked you to remember x squared, and then when it was horizontal, I always asked you to remember y squared. So the formula for vertical goes x minus h squared equals to 4p, remember the p? And then y minus k. So that was something like that was typically what the formula looked like for a parabola, and then for if it's horizontal, and vertical by the way is like that, and like that. And then if it is horizontal, then we start with y. So it's y minus k equals to 4p x minus h. So here we can see that the x is squared. Here we can see that the y is squared. Then the next one is an ellipse. So with an ellipse, almost looks like a circle formula. But then we've got a squared, and then b squared, and then there's a 1. So what's important about an ellipse was that we typically had it equal to a 1, and there was a plus in between them, and these numbers at the bottom were different. So so you see how a circle and an ellipse are very similar. So with a circle, I want you to think of the same. So what I mean by that is x minus h squared plus y minus k squared equals to r squared. So if there were numbers at the bottom of a circle, these numbers would have to be the same, for example. Okay? If it's an ellipse, then they must be different. And then there must still be a plus for both of them, like that. Hyperbola, this is the one that has a minus in the front, so you could either get it like that. If it's like this, where the x is with the a, so the x is in the front, then that was the horizontal hyperbola, where it went like this. And then if it is written with the y first, the a is always in the front for a hyperbola, then this one was a vertical hyperbola, like that. So let's get started. So the first thing I would do here is, well, you should realize that, so let's quickly show you something. For a circle and an ellipse, hyperbola, the x and the y are always squared. X is squared, y is squared. X is squared, y is squared. X is squared, y is squared. It's only the parabolas where one of them is squared. So here you can see the x is squared, but the y is not. So this must be a parabola. Yes, it doesn't look like the standard scenario, but it's still a parabola. Okay, so here we definitely have either a hyperbola, an ellipse, or a circle. So you see how it has a plus. So because it has a plus, then it's either going to be an ellipse or a circle. The next thing is to realize that even if you wanted to make this into a 1, you could do that by dividing everything by 10. And you'd end up with this. Note that these numbers are the same, so this is a circle. Here we have x squared and we have y squared, so it's definitely could be a hyperbola, a parabola, or an ellipse. Notice that there is a negative that instantly means it's a hyperbola. Here we have x squared and y squared, so once again that cannot be a parabola. It has to either be an ellipse, a hyperbola, or a circle. Notice there's a plus in the middle, so it can either be an ellipse or a circle. Cannot be a hyperbola because that would have a negative. These numbers are different, so it's an ellipse. Here we have only a y squared, but the x is not squared, so that instantly means this has to be a parabola. Now sometimes they're not going to give you a standard equation. Sometimes they're going to give you an equation that looks like this. So what you need to do is quickly look at the following. Look at the x squared and the y squared. That's all that you need to do. So that's definitely not a parabola, because a parabola has only one of them squared. Look at what's in between them, a plus. So it's either going to be an ellipse or a circle. The next thing, look at the numbers in the front. Are they different or are they the same? If they are the same, then it's a circle. If they are different, then it would end up being an ellipse. After we converted it, it would end up being an ellipse. So this one is an ellipse. For this one, look at the x squared, look at the y squared. They're separated with a negative, so that's instantly a hyperbola. You only look at the x squared and the y squared. You don't have to look at anything else. Look at the x squared, look at the y squared. They are they're plussed, so it's either going to be an ellipse or a circle. Look at the number in the front. It's a 1 and a 1, so they're the same. So this one is a circle.